So unsupervised learning is the class of machine learning algorithms that deal with unlabeled data. Now, in these techniques, machine learning algorithms on its own identify patterns that can create inherent groups within the dataset. Now, two major examples, we have clustering and association rule mining. Clustering is the first part. Let's handle them one by one. Clustering is a technique whose key objective is to identify distinct groups. These groups are also called clusters based on some notion of similarity within a given data set. Now, there are different types of clustering. We have agglomerative clustering, which is hierarchical clustering, and then we also have divisive clustering, which is the most popular algorithm under this technique would be K-means. Now, to understand clustering in a more simple way, just take into account, let's say you have a group of 100 students, and your job is to divide them into a group of 4. You have to divide them into 4 groups. Now, the algorithm will take into account similarity. It will measure similarity between different students, and it will create 4 groups or 4 clusters such that the similarity differences within the group is minimal, and the similarity difference between two distinct groups is maximum. So in that way, you'll have the most similar elements or objects in the same group. And in that process, you form several other groups. Now, the problem with divisive clustering, let's say like k-means clustering, the biggest challenge over here is we need to identify k. That is, you already need to understand how many clusters that you would need to create. The algorithm will start with the defined number of clusters according to you, and then find clusters for that number. So if you say you want to find 5 clusters, the data sets will be organized into 5 different clusters. Now, how do we arrive at K? There are a few techniques like elbow curve and Snoit method, but then we'll get that later. Another technique, agglomerative technique, starts from the bottom part. Let's say if you have n number of data points, it starts with n clusters and then combines the two most similar clusters together and repeats this process and finally reaches a point where it has just one cluster. So the process might be less intuitive if I talk about it, but let me explain you this visually with an example of our visual tool. We'll start with a basic example of k-means clustering. So please refer to this diagram. Let's say on 2 dimensions, I have defined several data points. I'm just restricting it into 2 dimensions because it's easier to understand or visualize them. Now our objective is to perform k-means clustering. And here, let's say for some business reasons, we have defined k as 3, which means that we have to find 3 clusters. Now, the way the algorithm works, it would be, now since you have defined k is equal to 3, it will start by randomly assigning 3 points. So let's say I'll assign this one, and let's say this one as the center for 3 different clusters. Now, the next step would be, it will calculate the distance from each of these data points. It will calculate the distance between these 2 points, and these 2 points, and these 2 points, and these 2 points. Similarly for these 2 points, and then repeat the process. And in that process, it will identify and create 3 clusters based on similarity value. Let's say after the first iteration, it kind of identified 3 clusters where it has found simple values, like let's say this was the first cluster, this was the second cluster, and this was the third cluster. Now once the first step is over, it will recalculate the center for each cluster. So it will calculate the centroid for this cluster. This cluster center will be somewhere here. So we have a new center point. This class center, let's say somewhere here, and let's say somewhere here. Now based on these centers, it will recalculate the clusters again. Now in this process, the moment center is shifted, a couple of points which were initially in this cluster might move to this cluster, and a couple of points which were in this cluster might move to this cluster, and this process repeats again. Now at the end of step 2, you might find relatively different clusters. So based on the 2 different data points we have, we might have a cluster which might look like this and like this. So, okay, just one caution word. No two clusters will have the same element. So it's something like this. All right. So this is the second iteration, and this is at the end of second iteration, where we have three clusters where which is fairly different from the first one. Now again, we repeat the same process. We find the new center for this cluster, which might be, let's say, at this point, and for this one at this point, and for this one, let's say, at this point. And we keep repeating this process. At the end of a couple of iterations, you'll find that the clusters are no more changing. You don't really see a lot of changes in these clusters, and they are fairly stable. But that is the final cut. You would say at this point, you have clearly identified the three clusters from where you don't have any more variations, which means that you have found the combination of clusters which have the maximum variance between clusters and the minimum variance within the cluster. So that's, in a nutshell, k-means clustering. Now, on the other hand, if you talk about hierarchical clustering, they start bottom up. So let's say you have a couple of data points over here. Now, what will happen is it will first create a cluster by combining the two most similar data points. Now, initially it will start with 5 clusters. So this will be cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. If it had n number of data points, it would have created n clusters. Then it will calculate the similarity between two clusters, and then these two clusters, and again these two clusters, and then these two clusters, and find out the similarity between each of them. And it will combine the cluster which is the most similar in nature. So let's assume for simplicity, cluster 1 and cluster 3 are very similar compared to all others. So it will create a new cluster by combining cluster 1 and cluster 3. In the next step, it will try to understand cluster 1 and cluster 3 as a single cluster. And look at cluster 1, and this is the new cluster. This will be cluster 2, cluster 4, and cluster 5. In this process, it might find that, okay, the next most similar cluster would be cluster 2. So this will get aligned with this cluster. So we'll have cluster 1, union of cluster 2, union of cluster 3. Then it might join cluster 1, 2, 3, and 4, and then let's say finally 5. So in this process, it goes on adding up. Now, as you see this, at one point of time, let's say I just speeded this process up. Had I not done that, so this would have created a cluster by combining these two. So that will have created something like 1 union 2 union 3 union 4. This is a new cluster, and this would combine with this to form 1 union 2 union 3 union 4 union 5. Now, at any point of time, when you decide what is the maximum number of clusters you would want, you can just give a cut at that point of time. Let's say you want 2, you can just go and give a cut over here. And you can have 2 clusters. One of them is this one, and the second one would be this one. Let's say you wanted more than 2 clusters. You want to find out a scenario where you have, let's say, 3 clusters. You can go to the next level. You can give a cut over here. So you have 3 clusters. One, this is the second one, and this will be the third one, and so on. Now you can repeat this process. You can go to a level where you'll have n clusters or 1 cluster. But the topmost level over here will have just 1 cluster, and the bottommost level will have n clusters. Now this is hierarchical clustering. The con with hierarchical clustering is it's a very time-consuming process compared to k-means algorithms. And one of the most widely used algorithm for clustering is k-means. Now, coming back to literature, let's discuss a couple of important points. Now, how do you understand difference or similarity between two objects or 2 data points? Now, the most easiest way of understanding distance between 2 points will be the Euclidean distance. So, if you want a demonstration again, let's go back. So let's say we have, for this previous example, let's say we want to calculate the distance between these 2 points. The distance between these 2 points, let's say the first one is x1, and let's say the first one is a, and the second one is b. Now, since it's 2 dimensions, they will be defined as x1, y1, and second one would be x2 comma y2. Now the distance between a comma b or the similarity of a comma b can be defined by the Euclidean distance formula, which is given as the square root of y1 minus y2 the whole square plus x1 minus x2 the whole square. Now this would give you the Euclidean distance. Now if you repeat this process, now this will give you, let's say, a value which is d. Now if you repeat this process throughout the matrix, throughout the values, you'll have values between these two values first, and then these two values, and so on. So you can calculate distance using a very simple metric like Euclidean distance. Similar to Euclidean distance, you have several other techniques to calculate distance. But Euclidean is the most popular and the easiest to compute. So that's a bit about clustering. Let's take a simple Python example to understand how we can implement clustering in a codified way.